Welcome to today's class. Today's class is actually a continuation of set part 2. So today is set part 3. Set part 3. And in set part 1, we defined the set and we defined some terms. Even in set part 2, we also did the same thing. So we are continuing from set part 2. So today's class is set part 3. And so set part 3, we want to define equivalent set. So equivalent sets that contain the same number of elements. They contain the same number of elements. In other words, they have the same cardinality. They have the same cardinality. Remember, under set part 2, we define cardinality of a set as the number of elements in that particular set. Cardinality of a set refers to the number of elements in that particular set. So equivalent sets are sets that contain the same number of elements. In other words, they have the same cardinality. For example, if you have a set like this, A is equal to 1, 3, 7, 11. And you have another set like this, B is equal to 14, 20, 30, 33. These two sets are equivalent. These two sets are equivalent. Why are they equivalent? Because they contain the same number of elements. In other words, their cardinalities are the same. In set A, the cardinality of set A is 4. In set B, the cardinality of set B is 4. So it therefore means that they're equivalent. So two sets are equivalent if they have the same cardinality. Power set, the set of all the subsets of a set X, is called the power set of the set X. Power set is simply a set of all the subsets of a particular set. A set of all the subsets of a particular set. And then the power set is usually denoted by this. The cardinality of a power set is given as 2 raised to power n. The cardinality of a power set is given as 2 raised to power n. For example, if we were asked to find the cardinality of this power set, the answer will simply be 2 raised to power 4, which is 16. So the cardinality of a power set is simply denoted as 2 raised to power n. And so we have some examples here, 2 examples or 3 examples. The first one is P is equal to, or P is a set of 2x such that 1 is less than or equal to x is less than or equal to 5. And now Q is a set of x plus 1 such that 2 is less than or equal to x is less than or equal to 7. Where x is an integer, what is an integer? An integer is a whole number. An integer is a whole number. So where x is an integer, P and Q are subsets of the universal set. The universal set is a set of x such that 1 is less than or equal to x is less than or equal to 10. Now we are to use this information to answer questions 1 and 2. We are to use that information to answer questions 1 and 2. And let's see how we can do that. First of all, we need to find the universal set. Let's find the elements of the universal set. Remember, we said in, I think, set part 1 that the universal set is the background set upon which elements of all other sets can be derived from. So elements of set P, elements of set Q that are gotten from the universal set. So let's define the universal set. Set of x such that 1 is less than or equal to x, so it means it will start from 1, 2, 3, 4, 5, 6, till it gets to 10. Those are the elements of the universal set. And now let's look at P. Elements of P. P is a set of 2x such that 1 is less than or equal to x is less than or equal to 5. That means when x is 1, we will have 2. That's 2 times 1 is 2. When x is 2, because x is running from 1 to 5. From 1 to 5. So when x is 1, this place will be 2 times 1, which is 2. And when x is 2, that will be 2 times 2, which is 4. When x is 3, that will be 6. And when x is 4, that will be 8. When x is 5, that will be 10. That's all. And then let's look at Q. Q is a set of x plus 1 such that x runs from 2 to 7. X runs from 2 to 7. So when x is 2, this will be 2 plus 1, giving you 3. When x is 3, we'll have 4. That's 3 plus 1. And when x is 4, we'll have 5. When x is 6, we'll have 7. When x is 2, we have 3. When x is 3, we have 4. When x is 4, we have 5. When x is 5, we have 6. And when x is 6, we have 7. When x is 7, we have 8. Those are the elements of the set Q. Alright. So we are to use that information and answer question 1 and 2. And what is question 1? P intersection Q complement. So first of all, let's find P intersection Q. P intersection Q simply refers to a set of all the elements that the two of them have in common. Set of all the elements that the two of them have in common. They all have 4 in common. They also have 6 in common. They have 8 in common. So that is P intersection Q. That is P intersection Q. That's P intersection Q. Alright. Now, but we were asked to find the complement of that. So P intersection Q complement simply refers to all the elements that are in the universal set but not in P intersection Q. All the elements that are in the universal set but not in P intersection Q. So let's look at it. 1 is there. 1 is in the universal set but not in P intersection Q. 2 is there. 3 is there. 5, 7, 9, and 10. So that's the answer to the first question. That's the answer to the first question. All the elements that are in the universal set but not in P intersection Q. So quickly we look at number 2. Number 2, P union Q. Union simply means set of all the elements that are in the two of them without repetition. Set of all the elements that are in P and Q without repetition. So we have 2, we have 3, we have 4. There is 4 here, there is 4 here, but you will not repeat the element. We also have 5, we have 6, we have 7, we have 8, and then we have 10. That's it. That's it. So that's the answer to question number 2. Let's look at question number 3. Let's look at question number 3. Let B be the set of x such that x squared is equal to 4. B is a set of x such that x squared is equal to 4. This command means and x is odd. In other words, x is an odd number. Now, what sort of set is that? First of all, let's define it. X squared is equal to 4, which means x is the square root of 4, and the answer is plus or minus 2. Plus or minus 2. But in the question, you were told x is an odd number. So this answer we are having is even number. As you can see, 2 is an even number. So since 2 is an even number, it contradicts what is here. Because what is here, you are told x is an odd number. So it simply means that it is an empty set. There is no set like that. It is an empty set. That's the answer to it. So with that, we have come to the end of this class. We have come to the end of set part 3. Do well to click the subscription button if you are coming across my video for the first time. Bye for now.